Hi everyone. This video covers 13.4 compound probability. There are two objectives. Number 1, to identify independent and dependent events, and number 2, to find compound probabilities. A compound event oops, I just realized that event was written here. My bad. A compound event is an event that is made up of two or more events. Alright, let's talk about independent probability and dependent probability. The occurrence of event A does not affect the probability of event B and vice versa. If that is the case, these two events are independent. For examples, the probability of it raining in New York and Mrs. Hooper winning the California lottery. Those are two events that do not affect each other at all. Number 2, the probability of having a birthday and the probability of being sick. Those are two events that do not affect each other at all. I'm going to let you guys come up with an example for here. Now, dependent probability. This is when the occurrence of event A does affect the probability of event B and vice versa. For example, the probability of it raining and seeing an umbrella. Because obviously if it rains, probably there's going to be some more people carrying umbrellas out there. Okay, so whether or not it rains will affect the probability of you seeing an umbrella. Also, the probability of having a cold and taking medicine. If you have a cold, you are more likely to take medicine. So these two events actually affect each other. I'll let you come up with an example for number 3. Okay, so these 4 items here, I'm going to let you guys try these and we will go over the answers in class. Let's go down to compound probability. Alright, 2 very important words that you're going to want to watch out for when you're dealing with probability problems. The word and means the combination of both outcomes happening together. The probability of A and B, the probability of event A, and the event B occurring. So, I don't know, the probability of flipping heads on a quarter is, of course, 50%. The probability of rolling a 3 on a 6-sided die is 1 out of 6. The probability of doing both of those things, getting heads and rolling a 3, would be 1 over 2 times 1 over 6. You multiply the probabilities of the two events together. Okay? Now, or means any combination of just one event or just the other event or both events happening together. So if I said, what is the probability of A and B of flipping heads or rolling a 3, you would, rather than multiplying them together, you would take the probability of the first event and add it to the probability of the second event. Okay, so very important here. Let's look at some examples. Alright, I've turned to the next page. Oh, before we do some examples, a note here. 2 events that cannot happen at the same time are said to be mutually exclusive. For example, you cannot roll a 2 and a 5 on a standard number cube at the same time. If you're rolling a die once, you're only going to get one of those 6 numbers. You can't get 2 of them. Okay, so if A and B are mutually exclusive events, then the probability of A and B equals 0. Alright, let's take a look at some examples. Okay, example number 1. A desk drawer contains 5 red pens, 6 blue pens, 3 black pens, 24 silver paper clips, and 16 white paper clips. If you select a pen and a paper clip from the drawer without looking, what is the probability that you will select a blue pen and a white paper clip? Okay, so let's make event A be selecting a blue pen. And event B, this is going to be the white paper clip. Okay, so we are trying to find the probability of A and B. Okay, now if you think about it, if I'm selecting a pen from my red, blue, and black pens, that is not going to affect the number of paper clips in the drawer. Likewise, if I'm selecting a paper clip, that's not, or from my white and silver paper clips, that's not going to affect the number of pens in the drawer. Okay, so these events are independent, and because they're independent, the probability is going to be probability of A times the probability of B. Okay, the probability of A, I'm going to come over here so there's a little more space. There are 6 blue pens, and there are 14 pens total. Okay, and probability of B, well, there are 16 white paper clips, and there are 40 paper clips total. Okay, so here I can simplify some stuff. 6 and 14 both divide by 2. 16 and 40 both divide by 8. And then if I multiply across, I'm going to get 6 over 35, which is approximately 0.171 or 17.1%. Let's do this other one. Student athletes at OLP may participate in only one sport each season. During the spring season, 39% of student athletes play lacrosse, 15% are on the swim team. What is the probability that a randomly selected student athlete plays lacrosse, that a randomly selected student athlete plays lacrosse or is on the swim team? All right. So I'm going to move the paper a little bit this way. First of all, it's important to note that student athletes at OLP may only participate in one sport per season, so it is impossible for a student to be playing both lacrosse and swim at the same time. Because of that, these are independent events. This "or" is important. We're figuring out the probability of A or B. So this is the probability of A plus probability of B. Let's make A lacrosse and B swim. So the probability that a student plays lacrosse is 15%. The probability that a student is on the swim team, oh, I'm sorry, I switched those, 39%. And the probability that a student is on the swim team is 15%. So, if I add these two together, I'm going to get 54%. So the probability that a randomly selected student athlete plays lacrosse or is on the swim team is 54%. Okay. Now let's talk about overlapping events. Overlapping events have outcomes in common. For example, the event of rolling an even number and the event of rolling a multiple of 3 overlap because a roll of 6 is a favorable outcome for both events. Okay, so when dealing with overlapping events, the probability of A or B is the probability of A plus the probability of B minus the probability of A and B. Okay? The reason you have to subtract the overlap is because this already takes into account the overlap. If you don't subtract it, you'll actually be adding that overlap twice. Okay, so let's see here. Actually, let's just do this example. What is the probability of rolling either an even number or a multiple of 3 when rolling a standard number cube? All right, before I use this formula, I'd like to just solve this through logic, just from thinking about it. The probability of rolling an even number or a multiple of 3. Well, on a 6-sided dice, we've got even numbers are 2, 4, and 6. A multiple of 3 would be 3 and 6. So the probability of rolling a 2, 3, 4, or 6 would be a 4 out of 6. But notice the 6 is duplicated, so if you were just to use this formula, you would do 3 over 6 plus 2 over 6, and you would end up with 5 over 6, not 4 over 6. That's why you have to subtract this. Otherwise, you're going to duplicate the overlap. In this case, the overlap is the number 6. So, let's make event A the even number and event B the multiple of 3. So the probability of A or B is the probability of A plus the probability of B minus the probability of A and B. The probability of rolling an even number, well, we got 3 of them. This is 3 out of 6. The probability of rolling a multiple of 3, 2 out of 6. The probability of rolling an even number that is also a multiple of 3, that's the overlap. It's just 1 over 6. 3 plus 2 is 5, minus 1 is 4 over 6. So 4 over 6, this is also 2 over 3. All right, I'm going to let you guys try this last problem. We'll go over the answers in class. Okay, finding compound probability. In order to win a game, a player must roll a dice once and get a 5 and then flip a coin and get a head. What is the probability that a player will win on his turn? Well, there we go. Okay. The probability of rolling a 5, of course, on a 6-sided die, there is only one 5 and there are 6 possibilities. There's nothing to simplify there. The probability of flipping a coin and getting heads is 1 over 2 because there's only one heads and there are 2 possibilities. The probability of rolling a 5 and getting heads is probability of 5 times probability of heads, so 1 over 6 times 1 over 2, or 1 over 12. Alright, I'm going to let you guys try these ones here, and I think I'll also let you guys try this one down here. We'll go over the answers in class. Let's go to the back. Actually, you know what? I think all of these you guys should be able to do. So go ahead and give these a try, and we will go over the answers in class. Alright, that's all the notes for this section. Thank you so much for watching.